Hello, everyone, and welcome to today's SANS webcast, Immunizing Modern Application Frameworks, sponsored by RunSafe Security. My name is Jessica Gallis of SANS, and today's featured speakers are Shane Fry, VP of Security Engineering, Nick Ria, VP of Market Development, and Kenton Brazil, Senior Sales Engineer from RunSafe Security. If during the webcast you have any questions for our presenters, please enter them into the Q&A window located on the control panel at any time. Please note that this webcast is being recorded, and a copy of the slides and recording of this webcast will be made available for viewing and can be found on the SANS webcast archives. And with that, I'd like to turn the webcast over to Nick.
Thanks very much, Jessica, and good morning or good afternoon or perhaps good evening to everyone out there in the world. We appreciate you joining us today. As Jessica mentioned, I'm Nick Ray. I lead our market development team here at RunSafe. And you'll see on the screen here, we're going to talk about immunizing modern application frameworks there. That's a bit of a loaded statement, so I want to just spend a minute or two unpacking that so you get a sense of where we're headed today. So immunizing code is what we're all about. We'll get to that. And we're going to walk through some interesting use cases and some research that we've done in partnership with SANS and within academia. And when you think modern application frameworks, you might be thinking LAMP stack, mean stack, and that definitely is part of what we're going to be talking about today. And you'll even hear some specific details around an exploit within that. But we're also going to be just kind of covering at a higher level the general challenges of securing open source and open source code, which is often found and is part of modern application frameworks, and also talking a little about modern application architectures and containerized based applications, microservices based applications, and how can you immunize code in those types of environments. So all that's going to be covered today. I want to do a quick intro for the folks that are going to be presenting today. And so obviously myself leading the market development team, but the real power that is going to be delivering the information that is the nuts and bolts of how we immunize software and how you can as well is going to be from Shane Fry, who leads our engineering team, spent a bunch of time on the offensive side of cyber. He'll unpack some cool stuff around a real world exploit. And Kenton Brazil, our senior sales engineer, who is going to walk through a live demo. So the agenda for today, I mentioned a real world exploit, a real world open source vulnerability. Shane's going to be leading us through that in just a minute. And then we'll talk about some of the key challenges around securing these modern frameworks against the backdrop of some research that we've done with the North Carolina State University team there that we worked with to analyze a broad swath of open source code and vulnerabilities within that. And then talk about a cool new approach on how you can immunize your software from attack and dive into some of the technology there. Then as promised, we will have a live demo of how this works within an open source environment. And then we'll close out with some deployment methods and real world examples just to put some context around all the technology that we'll be unpacking here in the next hour. So with that, I'm going to hand it over to Shane to walk through a real world open source vulnerability. So Shane, over to you.
Thanks, Nick. So as Nick mentioned, we're going to walk through kind of at a super high level, a real world vulnerability. We actually had SANS do an assessment of our tool, and that's where this assessment result came from. The paper for that's still being finalized, but basically what we had SANS do was assess whether or not the Alchemist technology that we develop in-house is capable of preventing exploits. And so two open source applications that got looked at were PHP and Apache because they had a vulnerability CVE 2019-0211, also known as Carpe Diem, that was in both Apache and PHP. And so the cool thing about that is it's open source software that we provide as part of our repo packaging, at least for Apache. And we could reproduce the vulnerability. There was a proof of concept exploit out there that was pretty reliable, actually very reliable. And it's two different types of exploits. We've got a use after free in PHP, which is more of like a type confusion type bug, where you could allocate an object of a certain type and then cast it over to be a string and use that to get arbitrary read write in memory. And then on the Apache side, there was an out of bounds write that was occurring. And then basically you could take that, and when Apache did its graceful restart every day, the root process would read an invalid structure for the tasks that it was supposed to execute in restarting its process. And then you'd have arbitrary code execution there. So two different types of exploits and two different types of problems that you can immunize against. And they were memory corruption, privilege escalation, and then finally the payload was actually through a return to libc type attack. And what basically happened there was you could upload a malicious PHP script to a web server, and when PHP parsed it, that's what initialized the state needed for the exploit to work. And then once a day, Apache does this graceful restart, and the payload got executed that way. So Kenton, if you want to go to the next slide. So how do we disrupt this, right? It's a memory corruption bug. So all of your static and dynamic testing of your web applications that are running on Apache and PHP aren't going to find this, right? It's a bug in the actual web software stack that is hosting your application. And so as we talk about securing software and modern web applications, modern web frameworks for the rest of this talk here, we want to keep in mind that you should still do the standard testing that you're doing, but you also need to think about these open source solutions here. And so how did we disrupt that Carpe Diem? Well, we took our Alchemist product, we applied it to libc and the HTTPD Apache web server. And then what that did was when Carpe Diem does its local file access to build all the information it needs to reliably exploit the system, we have a load time randomization that made all that information not useful. And so that randomization there broke the reliable exploitation and basically made the attack dead on arrival. So now that we've given you a low-level example of how an exploit can be mitigated, let's step back to the other step back and actually talk about how we can immunize software more generically.
Thank you, Shane. Appreciate you walking through the the real-world exploit there, and I am attempting to advance the slide, and there we go. Okay, so as Shane kind of pointed out, we're talking about filling in this gap here at the point of attack within code itself. And so the general notion here is that as attackers seek to execute different stages of their kill chain, they're going to need to traverse through all the traditional defense in depth or perimeter-based protections that are out there. And they're all important. They all need to be done. So don't misconstrue, but the firewalls, VPNs, intrusion detection system, authentication, scanning, encryption, all of these things are absolutely required. And at some point, though, they will be breached if an attacker is enterprising enough when they reach that point of attack where they're then attempting to run an exploit at the code level within the code itself. What is left to help you? That is the question. And how do you fill that gap? And that's where RunSafe comes into play. So I want to spend just a minute or two talking about RunSafe and our mission to set some context, give you a little bit of a backdrop on the content we'll walk through the remainder. And our mission is ultimately to disrupt hacker economics by immunizing software from a whole class of cyber attacks in that memory category, as Shane was talking about earlier. And there's a couple different ways to look at that, right? We know that as attackers or as defenders, we have to plug every single hole in our system, and that an attacker need only find one. But if we can find a way to take a whole bunch of those different potential holes in the system off the table, well, then that equation starts to change a little bit. And then we also know that as humans, we only have so many hours in the day to get our work done, and attackers are subject to those same constraints. And if they have to spend more and more hours trying to find a way in, well, they'll likely just pick a different vector, a different target, a different method to try to compromise the system. And then finally, Shane maybe alluded to this briefly, but I'm going to expand on it a little bit. The founders within RunSafe really were born out of the offensive side of cyber, helping to facilitate intelligence objectives. And there was a particular attack method that seemed to work over and over and over with high levels of success in achieving those mission objectives. And that was against memory-based corruptions attacks. And there are various different methods within that broader category. And so that leads to some of the research that we were doing that I mentioned with North Carolina State University just a couple months ago. And this go-to attack method, leveraging memory-based vulnerabilities, is really where the focus of this research was at. And there's a number of different open source packages that were analyzed in great detail and represented millions and millions of lines of code. Linux as a category was included in that. So that's obviously a very broad swath of what's out there in the open source space. And some of the interesting takeaways from that were that the most frequent type of CVE that you see out there is memory-related vulnerabilities. 40%, in fact, were in this category. But what's interesting about that is that out of all of the different types, memory really only represents 10%, but of the actual CVEs, it was 40. So they're very, very prevalent, even though of the overall types, it's a much smaller number. And moreover, what we found was that about almost 60% of the time, not only was there a vulnerability present, but there was an associated exploit script that could actually weaponize that vulnerability. So much more easy to actually make use of these in the real world. And then looking at severity against CVSS scores, generally speaking, on average, memory-related vulnerabilities were 7.2 to 9.8, with obviously the highest being 10, pretty severe. So when there are vulnerabilities and associated exploits, the damage can be pretty bad as compared to other categories where you're at a lower average CVSS score, 4.9 to 6.7. And then part of the research also involved looking at common scanning tools, the static code analysis, dynamic code analysis type of tools that are out there. And interestingly, out of all of the CVEs that were found just through public efforts that just made their way into actual validated CVEs, as compared to what was found through common scanning tools, there was only a 2.5% overlap there. So the scanning tools that are being used just aren't finding these CVEs that the general public is finding. But even when they are, this small number, the average mean time or median fix time was 567 days. So when they are found, which is not frequent, it takes forever to get them patched. So ultimately what this means is patching and scanning just don't work. They don't solve the problem. They can help, right? And you definitely need to do it, but they don't ultimately eliminate and have as much impact as we might like to think. And some other anecdotal occurrences within the last few months, in the last year, just within the last few months, Microsoft published a DNS-based vulnerability in Microsoft Windows that was memory-based and 17 years old. So well beyond the 567 days there. So these things can persist. And then last year, the number one ranking of the most dangerous CWEs from MITRE was memory corruption by a wide margin between 1 and 2. And also earlier this year, at one of Microsoft's conferences, talking about the vulnerabilities in Windows, 70% were in the memory category since 2012. So not something that you think about every day, but when the research shows that this is a broad category of attack that can be very, very dangerous, and so it's worth spending some focus on. So I'll shift gears there and then talk a little bit about the actual technology that we've developed to help with this, and we call it Alchemist. And it's a very straightforward approach. We take unprotected software that's obviously vulnerable to attack and ingest it into Alchemist as a transformation engine. And once the code is quote unquote transformed, passive protections, innate intrinsic protections are built into the code itself, allowing the code to protect itself from this whole category of attacks. And Alchemist as a solution is ultimately seamlessly integrated into an SDLC, a DevOps, DevSecOps pipeline in very simple manner, usually with just a few lines of code, a change in, say, a Docker file or in a make file. And Kenton will walk through some unique deployment options as well against open source packages here a little bit later. So how does this work? So here we'll get into the meat of some of the technology behind how memory corruption attacks are rendered inert. And it's something that's called Alchemist source because this particular method applies protections directly to source code. And the underlying technology within Alchemist source we call load time function randomization, which is very intuitively named. Its focus is applying randomization at load time to functions within a program. So on any given system, as a program loads, looking at the image at the left, bottom left, the kind of the orange stack, each of those block represents a function and a memory address location in memory on a target system. So when a program loads, function 1 calls 3, 2, 4, and 5. And that's consistent, the function order, no matter if you're hard with Alchemist or not, because obviously the program needs to run. So you have to preserve that flow, that call flow. But there could potentially be a memory vulnerability that's in one of those functions. And in this case, we're calling out function 5 on the left. And so an attacker, when they find or are aware of that vulnerability in function 5 and in that memory address location at the very bottom, they can consistently attack that because they're in an unprotected system. That vulnerability is always in function 5 and always in that memory address location at the very bottom. But when Alchemist protections are applied, the vulnerability is still in function 5, but that memory address location, which is what the attacker relies on, function 5 is no longer in that location. All the functions are randomized at load time. So every single time a particular process spins up, a new PID spins up, a new program loads, whether it's at boot time, or processes spin up and down, the functions will be randomized, thereby rendering it near impossible for an attacker to effectively leverage any type of, just about any type of memory-based attack. And so to help you kind of, I think, take it to a little bit of a higher level and visualize what this really means, and a lot of the security practitioners that are out there probably are asking, well, isn't this like ASLR, address space layout randomization? And to a degree, yes, it is, but it basically puts it on steroids. So with ASLR, you're just moving the entire program around in memory. And with a simple information leak, of which those are common, ASLR is easily defeated. So by applying randomization at the function level, you get really fine-grained randomization. So binaries that are protected ultimately become logically unique, but they retain program functionality. It's important to call out that none of the source code is actually changed at all. So 100% of the human readable source code is preserved. The Alchemist source load time function randomization is applied during compilation. When code is compiled into assembly, we apply our protections there, hand it back off to the linker for final packaging, and then an executable can be deployed as it would normally be. So very straightforward process, but ultimately delivering protections that are far beyond any other techniques that have existed today, and can ultimately take 40% of the attack surface off the table. So with that, now that you got a sense of how the underlying technology works, I'm going to hand it over to Kenton to walk through a demo and give you a little bit of an overview of a way that we use Alchemist source against open source software that's out there in the wild. So Kenton, over to you.
Thanks, Nick. And as Nick said, I'm Kenton Brazel. I'm a senior field engineer with RunSafe Security. So I spent a lot of time working with customers, both in pre and post sale support, and as well as running through some of the demonstrations like we'll be doing today. So before we swap to the Alchemist Portal online, I wanted to highlight what Alchemist Repo offerings currently were, as well as what we'll be showing in the demo. Simply put, Alchemist Repo takes the burden off the customer of integrating Alchemist source protections into common open source IT infrastructure applications and gives the user a drag and drop replacement. While integrating Alchemist source during build time is very minimal effort, it's not uncommon that customers are unable or unwilling to modify their build process. Alchemist Repo images remove that concern, giving you protected software that is functionally identical right out of the box. While this turnkey integration is most mature for DevSecOps Docker environments, we are rapidly expanding these offerings to other platforms such that you can see here. Software components from web infrastructure such as Apache Web Server or Node.js, to databases such as Redis or Postgres, to development tools such as Python or Bash are all susceptible to attack. The sheer nature of open source means that the attacker has full insight with unlimited resources into finding a flaw that can be used against anyone running the same version. Alchemist Repo introduces binary diversity that destroys attackers' kill chains and removes the proven #1 threat to compiled open source code. This is a growing list of offerings and will be expanded both in application and platform. And if you have any questions or interest in something in particular, please let us know. So this is a quick view at exactly what is required to integrate and use Alchemist Repo images from a Docker perspective. As you can see at the top, there's an example Docker file with corresponding Docker build and run commands for Apache Web Server. At the bottom, you can see the integration of Alchemist Repo and the modifications needed to be made, highlighted in green. Changing the from line tells the Docker file where to pull the image from, which is now pointing to the Alchemist Repo. Important note, the original image of the software based off version has the same functionality, and every aspect of your environment will be maintained with Alchemist Repo images operating and performing the same as the original vulnerable image. Inserting your license key found on the Alchemist Portal is the only other requirement for operation. I encourage you all to check out the website, alchemist.runsafesecurity.com, not only to review the demos we'll preview today, but also to review these instructions and try these offerings on your own. Well, we can spend all day singing our own praises. We know that getting the capability in the hands of the customers is really what makes the difference. So lastly, I wanted to provide a quick visual preview of what we will be going over in the demo on the Alchemist Portal. And it's a live environment laid out in a multi-step process focused on Docker and various types of open source applications. The goal is to not only show the ease of use while providing instructions for your own applications, but to show that the hardened software works the same as the original. In step 1, we'll review ways it can be integrated into Docker before quickly shifting to step 2, which will show the base Docker run command of a Python image to run a hello world script. For step 3, we'll increase the complexity to show integration into a simple Apache Web Server Docker file, which will render an example HTML file in a side-by-side comparison. Finally, step 4 will integrate the use of 2 protected images. Nginx is a reverse proxy for the Apache Web Server through the use of the Docker Compose setup. This final step will not only show that build complexity is no issue, but also that hardened images can function easily in conjunction with each other. With that in mind, you can see the expanded use of Alchemist Repo to your entire stack of compiled software with no risk of undesirable effects. Let me screen share now to our Alchemist portal at alchemist.runsafesecurity.com, and feel free to follow along as well. And as I walk through this, all you have to do is go to the site and sign up, and it'll give you a 30-day access to all the demos and trials. So that access, just to point out, would be up here. You would see a register button, but I'm already logged in, so that would be the place that you would go to see. But also, if you're for purposes of trial, you want to go here and actually click on the account and find your Alchemist license key within that account information as well. So now that we're looking at the main page, I'll just kind of point a few things out. And the first thing kind of notice is this notional pipeline here, and talking about the two different places where we can integrate the offerings that are available from the Alchemist portal. So both Alchemist source at build time, and the Alchemist repo at deploy time, which is again that drag and drop replacement that we'll actually be going through in the demo. So kind of scrolling down here, you'll see some of the different platforms for Alchemist source. And this kind of shows you how to, if you want to actually play with some of the Alchemist source files on your own in your own environment, to either compile the open source code yourself, or if you have your own C or C++ compiled code, for example, in a Docker environment, you could go in here and follow these instructions. And again, your trial will unlock these and allow you to follow along and actually harden your own files in your own environment. So actually, I'll go back to the main page here, and we'll scroll down and actually look at some of the offerings, the top level offerings that we have for Alchemist repo. And I'll just click on Nginx here to kind of show you what we're looking at from the Alchemist repo page. So this is really where you'll go, that kind of mimics the setup of Docker Hub, and looking in here and seeing which version of Nginx you would need to actually replace the one you're operating from right now, and you can actually tab over and see the other different offerings we have. And again, this list is growing and expanding, not only in application, but also as new versions are released and updated, we also update our offerings as well. So what you would do here is basically, let's say you wanted Nginx stable, you could click on this and it would copy the from line, and I'll just drop this over here to show you. That's what the from directive would look like, and you would replace that in your Docker file or your Docker Compose. So this automatic tool upgrade is worth discussing. The Docker Compose example we have here, this tool is a continuation of automating sort of that drag and drop functionality that we kind of start with the messaging behind Alchemist repo, where you just replace what is there with something that we offer, and it again functionally operates the same way. We're just protecting it. So you would put your Docker Compose YAML in here, and this is an example of just a use case, and you could click harden, and it would go through and actually change all of these for you to actually point to the Alchemist repo versions. And then so you would basically drop in your Docker file or your Docker Compose or your Docker run commands, even click harden, and you would be able to just copy what is changed out of here into your own area and be able to test that out. So kind of with that explained, I'll actually jump over to the demo page now, and you can get there by clicking up here on the menu bar, and you'll see there's a couple of demos here. The one we're going to be looking at today is focused around Alchemist repo, but I kind of wanted to touch on these two first before we shift over completely. Building with Alchemist source goes into integrating the Alchemist source components specifically for Docker, and actually does it for the open source tool Redis. So that can kind of gives you a step-by-step and guides you through the experience of using Alchemist source. So if you want to kind of learn that, and as we went over already, what the steps are to change, you'll see that here live. and then this live exploit mitigation demo is a Hello World program. It's a password authentication program that has a buffer overflow vulnerability in it, and we actually show the exploit of it, explain the exploit, so that the user can understand how it works, and then how we prevent that from actually being successful against our hardened version. And so you kind of get that side by side before and after comparison of a live exploit being thwarted. So that one definitely is really cool, and you should check on your own as well. But what we're going to be looking at today is how easy it is to really use Alchemist Repo. So I'll jump into this one. And sort of the first thing I want to do really quick is kind of go over what you're looking at on the screen. On the left, you've got helpful tips and shortcut information, as well as the guide itself for if you're walking through this on your own. The upper right is a text editor for actually editing all the code that you'll be using for the demo, and the lower right is a live terminal. So, and I point all that out mostly to point that this is a live demo that's actually being run on a server. So nothing is pre-canned. It's all operating as you would on your own environment and through your own VMs and such. So this first step really is just kind of going over the highlights again that we've already kind of touched on. We're going to be looking at Docker run, Docker file, and Docker compose, and integrating Alchemist repo images in all three of those stages. So going to the second step, you'll see kind of a side-by-side example with a Docker run command using Python for actually just running this print hello world statement. And you can see the first Docker run command is going to pull the image real quick. I guess it timed out from when I was running this earlier, so this may take an extra second here to pull the original Python 3.7.7 Buster image from Docker Hub. And then what it'll do here is on this next command, once we're done here, we'll actually pull the image from our Alchemist repository, the same image, just hardened with Alchemist, and show that it operates the same way. Let me try this. Actually, looks like it's getting hung. At least you know that it's a live demo. Yeah, it should only take a second anyway. But yeah, some of the components we'll be modifying later. The Docker file, the Docker compose file for steps 3 and 4. You'll see some of those stored here, and then we'll actually use this hello world HTML that we're going to use to render. And you can see that we are now running. So click on this image. It's going to pull down again from our RunSafe repository and run and operate in the same way. I wonder. All right, I'm going to go ahead and go to the next step here. It'll take an extra second or two, but start briefing this kind of what we're doing in this step. And this is looking at the Docker file itself, and we're going to be building this image and then running that image in a container, and actually rendering that on this 8080 port. And I'll actually show after we run it, show that it's working and operating just as it would normally. And then we're going to rebuild the image and with Alchemist, and I'll show how we're doing that. But as you can see, it just finished here and operating again the same way, printing hello world. So let's go ahead and start the Docker build image, and that went quickly as expected. And then we'll actually run it and show that it's operating by clicking that link to open up on port 8080 here. So now we're gonna modify it, this Docker file, which was the original Docker file we built here. We're gonna change the from line by clicking that link, which will point to our Alchemist repo version of the image, and we'll perform the build. Exact same command, just integrated with Alchemist. And now we're going to actually run it, and we're going to add the license key as an environment variable during the run command, and you'll see that it runs on port 8081. And we'll click on this just to show that it's running, and you can see port 8081. So again, operating functionally the exact same way, just protected from attack. So going to the final step and actually getting slightly more complicated is looking at the Docker Compose file. And a lot of people who use Docker will know that this is a common way to stand up multiple components of Docker images. And so we recognize that, and we want to show it that it's easy to operate in that space as well. So the first thing we'll do is spin up Nginx and Apache web server by running this Docker Compose file that you see right here, which will create the network and start everything. And then we'll be able to actually click on this, and it'll render that same HTML. This link will show it port 8082 here, so you can see that it is indeed a different file. And now we're going to open the Docker Compose file, and then we're going to add the RunSafe images, both replacements for Apache and replacement for Nginx, and you'll see the changes reflected here. And then we're going to add as the environment variable the license key, pass that in as part of the Docker Compose, and then we're going to run the Docker Compose up command of the hardened version of this Docker Compose file. And actually, I'll go in here to the HTML just to show that it is rendering it, and modify that, and then pull it up, and you'll see that it actually, well, it didn't get that final change, must not have updated. There you go. And you can see that it's actively using the hardened components that we just passed in through the Docker Compose file. So with that, hopefully you understood, other than the little slight slowdown at the beginning, exactly how easy it is to add Alchemist protections and all these different types of variations. And I'll hand it back to Nick and pull the slides back up here.
Thanks, Kenton. Great demo. And as you can see, our portal is actually a live environment. So we really thought hard about wanting to give potential customers interested in kicking the tires an actual live environment. So everything you saw there, just there's nothing pre-canned about it, and I think even some of you out there went and registered live and hopefully went along with us or with Kenton. So that was great to see. So just make sure that you, if you do want to go, you can do exactly what Kenton just did. Just make sure you register, because the environment variable that you set for the license key is required on having an active login that generates the license key. And then you'll be able to execute that demo as well as the others that are there, as well as even pull in, the Alchemist source tool itself into your own environments and use that license key internally as you would like for 30 days. So again, thanks, Kenton, for running through that. Great example of how easy it is to deploy hardened open source packages, in a typical environment, Apache, Nginx being obviously very common out there. So I'll close out here with some real world use cases as well as kind of giving you a sense of where and how this could be deployed. And I think a lot of you probably piecing this together. But Repo as an offering includes Docker images. Kenton alluded to some other formats as well. But with modern applications being containerized, microservices based, and likely in the cloud, we put emphasis on ensuring that we would be able to support customers that are deploying in that type of an architecture. So the top three and four, or depending on the measurement of the day, but we wanted to try to cover as much as possible out there in terms of all the different containerized cloud container management and orchestration offerings that are out there. So AWS, Azure, Google Cloud, GCP, and Oracle Cloud Infrastructure. Really looking at all of the different containerized offerings that they've got, whether you're looking at ECS on AWS or EKS, or even Fargate. So kind of looking at, are you deploying containers and managing the full Kubernetes environment, or are you really just focused on the container itself and abstracting away all of the underlying infrastructure beneath it? At the end of the day, as long as you're managing the open source code itself, right, then it's applicable. So there's a lot of different ways in which you can tap into the hardened instances and deploy them in various different cloud services that are represented here. So that's lots of flexibility there, and don't be afraid of kicking the tires in these environments. And obviously, we're here to help support you in that. So as we move along, I wanted to mention too, I alluded to this, but outside of containerized images, we know that there's folks out there that are running VMs itself. Not everybody has modernized applications into a full containerized microservices architecture, and that's great. So one of the things that we focused on with Oracle initially is having base Linux images there in VM format, so running on, in this case, Oracle Linux images, non-containerized. And these are up on Oracle Cloud Marketplace right now. We started with Nginx, Apache Redis, and Memcached. But again, these have all of the Alchemist protections built in. They're ready to go. It's about as turnkey as you could possibly get if you are deploying infrastructure on OCI. You can quickly and easily deploy a hardened instance of these offerings directly from Oracle Cloud Marketplace. And to give you a sense of what that looks like, if you are OCI users, this should look somewhat familiar. This is within the actual OCI console itself, integrated with Oracle Cloud Marketplace. You click launch an instance and follow the process you normally would to deploy any other Oracle Linux-based image into an OCI environment. And the pricing is just integrated. You're not paying a separate license. It's not bring your own license. It's all bundled into the image itself. So again, a little bit even more turnkey for OCI users that are out there. So I also wanted to mention a couple of different real world use cases, beyond the exploit, but how is this actually being deployed and what types of environments out there? So Alchemist Repo is available obviously for end customers, but part of how we're bringing this to market is also to work with partners as well. So I'll start there. A leading CWPP provider, container workload protection platform, if you're not familiar with that acronym, but Atomic Corp is a partner we're working with. In fact, we just launched today, the press release went live this morning, an integration with that platform. And if you're not familiar with kind of that general category, Atomic Corp and others have aggregated a number of different cloud workload security capabilities into their products. At the end of the day, they're responsible for surveying, assessing, scanning the entire cloud environment that a customer might be operating on, or on-prem for that matter, for weaknesses and misconfigurations and things that might leave your overall IT environment susceptible to attack. And the feedback they were getting from customers was there's a gap, and how do we address some of the vulnerabilities that maybe patching and scanning doesn't get, right? And so it was a perfect fit, obviously. And so the use case there is we basically mirrored our entire repo library into their repository, and then as customers are scanning their environment and they're running the same instances that are in that library, they're offered an option to very seamlessly deploy these hardened images and swap out the Apache or the Nginx version that is running in their environment. So very, very simple turnkey kind of a use case there. Now, at the end user side of things, Estate Space is also a customer of ours that is in the fintech space and has deployed an application architecture that's highly modern and is very ultra secure because of the sensitive data that they're holding for high net worth individuals that are using their platform. So they did not have a choice. They had to deploy the highest standards of security in order to be able to play in that particular category, in that vertical. And they deployed hardened instances of Node across their infrastructure, as well as Nginx is being deployed today, and effectively removing about 40% of the potential attack surface from their environment, and thus enabling them to go to market a little bit more rapidly. They're now able to repurpose some of their security resources in other directions. So wrapping up, just to summarize some of the challenges that we've addressed here today, patching and scanning all vulnerabilities is just, it's really technically not possible. But what can you do to reduce the attack surface is ultimately the goal that we're striving towards with Alchemist protections. And we know that a lot of tools that are out there, like the scanning tools, tend to add a heavy burden on developers as well as security teams that are constantly trying to remediate against the onslaught of vulnerabilities, the mountain of vulnerabilities that continues to grow in many customers' environments. And so building remediation into the actual tool that you might be scanning or the open source package you might be scanning is a way to help with that. And we know that there's limited resources in general for remediation. You want to keep your developers focused on developing net new capability and getting products to market as quickly as possible, rather than continually tackling an endless stream of vulnerabilities that are being introduced through all the different open source packages that might be coming into your environment. So with that as well, I want to remind folks to visit Alchemist Portal. Again, that's where Kenton was spending his entire time. So you can go to that exact same website, alchemist.runsafesecurity.com, and execute the demo that Kenton did, as well as gain access to the Alchemist source software itself, and then all the documentation that you need to deploy it internally. And of course, we're obviously here to help you. So with that, want to actually ask Shane, who's been monitoring questions in the background, if there's any questions that may have come in that I missed.
Yeah, thanks, Nick. So one of the questions that came up is, what do we do if we've got open source software that's not currently in the list of repo packages on the portal? Is there a way for us to get those added to the portal?
Yeah, well, we'll reach out to you once you sign up on the portal, or you can just go to our website and submit a request for assistance. But if it's not there, let us know, work with us. And if it's technology, or if it's open source piece of software that is applicable to Alchemist source capabilities, if it's technically compatible, then we'll hand it off to the engineering team and they can harden it. Now, if you have an interest in actually compiling the open source package yourself, then we can help you with that as well, and deploy Alchemist source into your build process. So a couple of different ways to go about it.
Yep. And then got another question for you, Nick. So what's the turnaround time if there's, or I guess this is probably for Kenton, what's the turnaround time on a new version of an open source package being released and us being able to provide an update? Is it, are we going to lag behind 6 months, or is it a pretty quick turn?
Yeah, so we're advancing that capability. We've got we're looking at monitoring the set of repositories that we currently offer, and the kind of the idea right now is nightly checking them, and then providing updates and pushing those through our pipelines. That's still in the works. So it's a little more manual process right now, but certainly not asking customers to lag behind by months or anything like that.
Excellent. Shane, any other questions?
Yeah, we got one last one on the source offering that got mentioned, compiling and protecting your own code. What architectures do you support for that? Is it just Intel?
Oh, sorry, good question. I forgot to cover that earlier. It's a very important point. Yeah, processor architectures would be Intel, yes, to that one, as well as ARM and PowerPC, which covers a good portion of the market. So, and generally speaking, Linux across the board, Windows capability is there as well in certain use cases. So those are kind of the core elements. But generally speaking, if it's compiled code and it's running on Intel, ARM, or PowerPC, we've got you covered. That was it, Shane?
That was it.
All right. Well, thanks, everybody. I appreciate you joining us, and hopefully you found this educational and entertaining all at the same time. And with that, I'll hand it back over to Jessica.
All right. Thank you, Nick. So that's all the time that we do have for today. And thank you to our speakers, Shane, Nick, and Kenton, for that great presentation, and to RunSafe Security for sponsoring this webcast, which helps brings this content to the SANS community. To our audience, we greatly appreciate you listening in. For a schedule of all upcoming and archived SANS webcasts, including this one, please visit sans.org/webcasts. Until next time, take care, and we hope to have you back again for the next SANS webcast.